Welcome, everyone. If you're here to hear about Indeed Flex, you're in the right place. In the next 30 minutes, we'll be talking about the story of how we are using Confluent Cloud and Kafka to migrate a monolith architecture to microservices and quickly adopting new features and engaging customers to work with our revolutionary platform. Oops. Does the clicker work? There we go, sorry. So I'll start with introductions. My name is Ronak Patel. I am an engineering manager at Indeed Flex. And I've been with Indeed for about 9 years and with Indeed Flex for about 2 years.
And I'm Gayatri Veal. I'm a cloud infrastructure engineer working with large-scale data systems and with a focus in messaging and streaming data platforms. And Ronak and I work for Indeed. You've heard already from our introduction that this is the #1 job search engine. Indeed has over 300 million unique visitors every month. So that speaks for the volume we get. At the center of our core mission is the job seeker. We want to keep the platform free for job seeker to go and research about all their employers, potential contacts, and upload their resume and seek better employment. In short, Indeed is out there to help people get jobs. And, oops, that didn't work. At Indeed Flex, we help people get jobs instantly. So Indeed Flex provides job seekers with a fast way to find temporary work that fits their lifestyles. And we're committed to empowering workers with a great work-life balance through ownership, control, and choice with where, when, and how they work. And we do that through a mobile app that anyone can download. You can go to the Play Store or the App Store and download Indeed Flex. We operate in certain cities in the US, mainly in the UK, and then we're expanding throughout the US. And then we have an entire application system underneath that allows workers to be matched with employers, and then they can go and work any sort of shift that they're eligible to work for. And in order to help people get jobs and help people get jobs instantly, we need to help developers help people get jobs. So the first thing that we think about is, as an R&D group, is a developer-first strategy. We want to make sure that everything is self-service, including infrastructure and environments, be able to allow developers to create their own Kafka topics, create their own clusters if they need them as well. And on top of that, to do very easy push-on-green type of deployments with canary deploys and automated testing, CI/CD, and do all of that while still maintaining our legacy code systems, which are not able to do those things. So having that same connectivity between both systems while also enabling developers to move fast with new systems. So why did we choose to do all this with Kafka as our central piece in our data journey? As you heard, Indeed is very high volume data, right? You have data intensive applications deployed all across Indeed because it's dealing with a lot of data from all these job seekers. And Indeed is very data driven. So not just the volume, we are also cataloging several types of data and in high velocity. So what we decided around 2019 is we are not going to continue supporting monolithic architectures and monolithic software systems that are being worked by over a 50-person team and keeping the monolith in existence. We went to an API-first development approach. So you have your REST APIs, right, in Kafka, as well as we decided we are going to throw observable metrics at the end of each of these API so we can have valuable insights on if the service has value to a job seeker. And is that something we want to continue and upkeep? Our VP for data science, Donald McMahon, always says, if you can measure it, you can improve it. And that's exactly what we did with our APIs. We built a framework where each of these services not only attributed interactions and how the services are being worked with integrations, but also gave us insight into if this is something we want to continue upkeeping for cross-domain functions. So when it comes to Kafka, it's no-brainer. It's a low-latency distributed log, and it's replicated, structured, And you've already heard in the key note when Jay Krupp said it's an immutable log, which means it's only append only, and we can have that for all of our teams across Indeed to use and function. We also use it in our data integration, so we have many disparate sources and sinks across the company and a big data lake implementation, so we have several connectors in play. And we also use it for write-ahead logs sometimes for our business critical data-intensive applications. Before we started on this journey with simplification, if you will, we had to choose a partner, so we chose Confluent, only for 2 reasons. We didn't want to run Kafka at scale ourselves. We wanted to have that be a managed platform, and we wanted to focus particularly on domain-driven design for our API endpoints. And what that means for Indeed Flex is sponsored jobs, interview management platforms, and the hiring platform. The domain and design specifications are very important to get down before you go and build something like this across domains. Apart from this, you also have to think through your business rules that you're going to be defining within the domains as expertise, and your common adapters and frameworks and the drivers at play, so you support certain languages and have your downstream consumers able to use these data mesh sort of thing you're building out.
So let's talk about like the main core components of Indeed Flex. If you think of Indeed Flex as sort of a pipeline, there's 5 components to this. The first is candidate sourcing. We need to be able to get new job seekers into Flex. The next is HR compliance. So we need to be able to allow workers or potential workers to be able to onboard quickly to our HR systems. That includes background checks, includes payroll, direct deposit information. And we do all of this seamlessly through the app in a single workflow. After that, once they are actually onboarded, we need a staffing and fulfillment matching service so that we have a marketplace of workers and clients that work together to make sure that we are getting the right workers for the right jobs and the right shifts. And once the worker is matched to a shift that they choose, they need to show up to the job and be able to clock in and clock out seamlessly, and we do all of that through the app as well. And then as soon as they have clocked out of the app, we want to make sure that we get that information directly into our payroll systems, and so all of this is done through event sourcing. And as a result, we're able to pay our workers at least up to 50% of their earned wages for that shift on the same day that they worked within a few hours. So this is the 5 core components of Flex. And what did that look like at the very beginning? So in the very beginning, Flex was a giant monolith sitting in Heroku. It was a Ruby on Rails monolith with over 200 plus Postgres tables and several sidekick queues. And all of those 5 components were very tightly coupled. So if you were making changes in the payroll system, you probably needed to know how timekeeping worked upstream in order to make sure you don't make any unintended changes that would cause breakages. So they're very highly dependent and tightly coupled. The other problem was that this was an entire monolith, so if we wanted to scale out any of the specific components, we actually had to scale out the whole monolith. We couldn't really independently decompose and do scaling independently. Where do we end up now? So at the present moment, as we are transitioning to Indeed, we wanted to start leveraging Indeed environment more. Indeed is great in terms of the way that it's designed and structured its applications and services. It is a series of hundreds, if not thousands, of microservices that all work together in order to present the Indeed ecosystem. And we wanted to start building inside of the Indeed network and Indeed ecosystem. So part of that required us to move several of those components, and the ones that we moved were sourcing, compliance, timekeeping, and payroll into our Indeed AWS network and out of the Heroku monolith. These all became independent systems written in the languages that made sense, the languages and technology stacks that made sense for these specific business problems. They were all backed by their own databases, and then we source and we use Kafka for event sourcing, change data capture, and a few other streams processing applications in order to actually drive all of these business domains. We also created these separate REST and GraphQL APIs so that all these different components can also directly interact with each other if necessary. What does the future look like? Well, we don't want to be on two different clouds. And part of the reason for that was when we were on two different clouds, we needed two different types of clusters. We had a public cluster for the Heroku network, and then we had a private link cluster, a dedicated private link cluster for our AWS network. We want to actually move the rest of the Heroku stack into AWS, Indeed's AWS network, converge everything into our private link cluster, and get away with having to manage topics across multiple clusters. Indeed still has other clusters that we may connect with for different types of use cases like sponsored jobs or candidate sourcing. But within our own private link cluster, all of these individual applications and microservices can now interact and communicate with each other. This will allow us to have separate databases, allow us for improved scaling out independently, and then improve our ability to do analytics using Kafka as our data streaming platform.
So let's walk through what the journey looks like. I mentioned earlier, before you start on this journey of simplification, you have to define your business rules. Then I think you have to identify which components within Kafka makes sense for your microservices. And we made a choice, as you saw in the core component slide, for the timekeeper component, Kafka Streams was the most fit because it's just a library. You can easily deploy this at scale. And it has stateful processing, so we can throw some post-processing logic with time. Some of the earlier dimensions we had to go and define was, what is time? Is that wall clock time or the event time when a flex worker is triggering the activity? Apart from this, we had to get specific for our domain-specific functions that we would implement in our Java code. And we also had to figure out concurrency, so the topic layout and the number of partitions, and get specific for the threading of the Kafka instances themselves, so we can keep our producers and consumers at different configurations and scale out on demand of the specific segment Flex would be targeting. We are also learning from some of the recovery and deployment things with Kafka Streams that we have to think about standby replicas and persistent volume claims, so our deployments are faster and quicker and easier to maintain. As for our external services integration story, because Flex is crossing domains, we need to not only bring data from disparate sources and things as technologies like MySQL, Mongo, etc. We need to connect literally cross domains, as you saw with the Heroku cloud. So some of the early on exercises we did is refining our configurations and how we would get specific for standardization of these connector configs. In this particular slide, I've shown some of the things we did for our Postgres connector. We decided we would upgrade to Postgres 10 plus and use plugin name PG output because it's maintained by the Postgres community. We wouldn't have to upkeep that particular choice ourselves. And we also made a conscious decision to use JSON in the beginning, and you'll see in a minute like why we chose Avro in the end anyway. After choosing this initial configuration, we went through a benchmarking exercise. Ronak mentioned the Heroku database is a monolith and it had over 200 plus tables. So how do you go and bring all of that into this other microservices environment you're thinking about? We procedurally started with 4 of the largest tables, and we deployed separate connectors for each of these tables. The reason we did that was we could have the slot names be the PG replicas themselves, so we could scale out not just the connector tasks, but also the replica for the table that we are reading from. We also tuned compression, batch settings for each of these connectors, and even did some custom SMT for event routing. And through this repetitive exercise, we were able to figure out our fine balance of how much throughput we needed to bring all these Postgres tables into our AWS environment. So some of the things I want to point out is when you're coming up with your connect strategy, these are some of the things you would have to think about. The naming convention of the topic, the way you're going to scale out your connect task, and how would you go and read from your Postgres table so you don't end up locking the table or having blocking operations. So some things to be mindful about. As for our deployment with Kafka producers and consumers, we are reading cross domains, we are reading cross applications. It's better to keep them disjoint, right, and decoupled. So we are able to scale producers and consumers for each of the data pipelines. And so we are also, some of the things we are trying to work through is reduce the complexity in the logic. Some of the things we are using Kafka producers and connect framework is for persistence into a permanent data analytics, data platform, sort of historical data work. And we use the Snowflake sync connector for that sort of environment. We made a conscious choice for the publishers to not register the schema when they are coming up, right, the producers. We did a mono repo where all our producers and consumer applications can make changes to the underlying schema subjects. This enabled us to function cross domains, self-service independent needs, and also remain consistent for the versioning and compatibility requirements we had. Also, some things to point out here is, since you're going cross domains, you'd have to define data contracts, and the mono repo became the source of truth for our cross domain functions. As for compatibility and references, top 3 things to think about is your field ordering within the topic itself and your topic naming strategy. These things come to play when you're deploying new schema versions. Some of the things also we've learned is working with Confluent Cloud, always trust the API to make schema changes. Don't use the schema validator in the UI. And after playing with all the compatibility modes, backwards seemed to be the predominant choice because we had to go across teams.
All right, duplicate events. This is a talk that we could probably have for an entire 30 minutes. So I actually have some notes that I want to actually remember. So I'm going to pull those notes up real quick. If I can find the notes. There we go. So we've had to handle duplicate events in multiple different ways, depending on the use case at Indeed Flex. Where possible, we've tried to design our systems to expect duplicates, since Kafka guarantees at least once delivery by default. And so we make the consumer logic idempotent. Sometimes that's not possible. So we've looked at a few options. For Kafka streams, we've enabled exactly once semantics by setting the processing guarantee configuration to exactly once v2. And this will actually update some default configurations under the hood. For example, with the producer side, it will enable idempotence that will be set to true. And then on the consumer side, it will set the read committed, the isolation level to read committed, and among a few other configurations. This enables transactional awareness in the consume process produce loop for our streams, for the entire streams topology. So that's actually something that we've done with our timekeeping Kafka streams application. Outside of case streams, for applications that are really just simple producer consumers that are consuming from an input topic and then producing to an output topic, you can actually do the same thing, just setting those underlying configurations of enable idempotence and isolation level of read committed, and you would get that same level of transactional awareness. For consumers that are only reading from a topic and not producing to an onwards topic, we've started to explore this idea of like an idempotent consumer pattern. where the consumer will start a transaction with the database at the very start of consuming the message, do its processing, and then commit the message ID or the information at the end of the processing, along with the rest of any sort of updates it needs to make. In case something fails there, the entire transaction can roll back, and then you can reprocess that message. But if you, for some reason, do get the same duplicate message, you already know that it's already in the database, so you can basically skip it. Combining that with like a transactional outbox pattern on the producer side to make sure that as soon as you write to the database, you write to a outbox table, and then you have a separate producer that's actually reading from that table to publish, allows us to ensure ordering and then deduplication as well. On the CDC and Debezium side, we're actually looking to explore the exactly once delivery that's now sort of available in Kafka Connect. We haven't looked at it just yet, but it's something that we're interested in. So Kafka Connect now supports exactly once for source connectors in KIP 618 and with Kafka 3.3.0. And the biggest limitation right now that we have is the ability for Kafka to participate in two-phase commit, to dual write to a topic and a database within the same transaction, right? So we've heard this in the keynotes earlier. So we're looking forward to KIP 939, which will support 2PC, and we'll probably be trying that out as well. There we go. So some of the other things that we are really excited about with Confluent is how they help improve developer velocity. So at the very beginning, I was talking about how we want to help developers help people get jobs. Kafka is, of course, a very huge ecosystem, and there's a lot of things to learn and understand and do with that. But we want to make sure that product teams, application developers, are able to go and build on top of Kafka without having to have a dedicated Kafka team or a set of Kafka experts being gatekeepers around this stuff. So the Confluent's REST API, CLI, the Terraform module that they have, including a few of these other technologies that we've listed here, all of these things have been really used heavily at Indeed Flex, as well as the rest of Indeed, to enable developers, application developers, to drive feature development really quickly on Kafka. As for the observability side, we're really interested in this as well. We want to make sure that we are utilizing our clusters and utilizing our resources within Kafka in an efficient manner. And so Confluent Cloud's native integration with Datadog is something that we highly leverage. We use it for things like notifications. We set up Datadog monitors for our application developers, developer first responder system, as well as our SREs, to be able to get notified as soon as something is going wrong immediately, as opposed to waiting for someone to tell them downstream. We also have cluster level load metrics. We also do targeted notifications based on tagging and labels, so we know exactly which consumer group in the consumer group might be hitting lag, for example, and any sort of other granular metrics and attribution that we can use to help slice and dice this observability data in a way that helps us to get to the root cause as quickly as possible. Not only do we care about observability, we also care about cost attribution. So because we are a set of distributed teams, we don't have one giant team that's working on one giant monolith anymore. Every team is part of the same Confluent cluster, and so it's a shared resource. So we want to separate principal IDs per consumer. We want to also separate principal IDs per connector, as well as by source. And what this allows us to do is we actually are able to identify which are our highest cost resources currently running in our cluster. As you can see, the Snowflake Sync connector is probably one of the biggest ones for us. We are shipping a lot of data from our tables directly into Snowflake. And so we are able to use this information to help improve and manage cost. This little table that you see here is actually from our internal inverted index system called Imhotep. So it's really a distributed OLAP query engine built off of a columnar data store. And so what we do is we pull the data from Confluent's billing API and ingest it into our system called Imhotep, which you can read about on our engineering blog. And then we are able to build out these queries around our cost.
And at the heart of Indeed's core values is privacy and security. So we've heard some things we've done in the Flex journey on how we tackle with data in motion. But we have actors, right? And they all have privileges. So early on, we partnered with Confluent on tracking all the events that are happening within the Kafka environment. So we have fine-grained access control. We have much more roles than we had early on in Confluent Cloud now. And we also have specific events that we have to ingest into our Splunk platform, and we get anomaly alerts. So if there is a ransomware attack sort of thing or a DDoS sort of thing with a particular consumer or a producer even, we get notified and we are able to react to it after we funnel it through our SIEM at Indeed, which our security team maintains. We are also able to handle GDPR constraints like data drop and erasure requests, and we are able to use our SMTs to mask PII and PCI information on demand. So far you've heard how we put together Flex. Let's talk about how we refined our usage of Kafka, and Ronak pointed out, you paid for the cluster, might as well 100% utilize it, right? So we work purposefully with the Confluent Cloud engineering team and improved self-balancing algorithm. You can read about this on their blogs and documentation. What happened is we asked Confluent to procedurally balance the brokers, not just based on the storage and compaction limitations that brokers are reaching, but also based on the utilization, the CPU utilization, and run that at a faster incremental level, so the data is evenly distributed across the cluster, and we are getting even access across producers and consumers trying to use this cluster at capacity. Our understanding of saturation with the client connections and requests per seconds have improved. We've also learned a good understanding of when we are getting throttled at the network endpoints and when do we expand the cluster. So we just don't get click happy and keep adding CKUs for better performance. So once we figured out the control plane and how we deal with that sort of tuning, we started tuning procedurally our applications themselves, the Kafka streams, the producers, and the consumers. Some of the configurations instantly that can benefit anyone trying to tune your Kafka environment is listed here. We've also got a little bit more bold by experimenting with feature flags. Avro 2247 is a nice feature flag. If you're dealing with a large-scale monolith like we have, and you're trying to deal with faster reads on your schema registry, you can enable that switch and it'll give you instantly faster read. And it also improves the concurrency level and deserialization logic with Avro. We're also improving our logic surrounding managing multiple consumers on this one cluster. Ronak already pointed out how we do by principal ID, not just for connectors, but for each producer and consumer interacting with the cluster. And we have started enforcing client quotas. So in short, our journey would not have been possible if we hadn't decided to not use a monolith. And all I will say is, with Confluent's partnership and full streaming ahead, we help people get jobs instantly. Thank you.